Hello guys, I guess we are live now. Is my voice clear because my mic just turned off just before starting of the stream? Okay. Anyone? Let's just try. We're going to start with Leetcode Weekly Biweekly post contest discussion, and we are going to solve all the word problems in this contest. Can I get to know how many problems did you guys all solve? Okay. D is based on segment tree and LCA. Yeah, segment tree, pen victory, or I use pen victory and LCA. That's 3.2 easy. Yeah. Okay, so let's start with all the problems. Let's complete first three really ASAP because they are easy, and then we will move towards the 7 pointer of this contest. Okay. Oh, almost third. Uh, okay. So in this problem, you are given an array strings of word where each string represent a word containing lowercase English letter, and you are also given an integer weights of 26 size, where weight I represent the weight of the ith character. The weight of the word is defined as the sum of the weight of this character. Okay, easy. Now for each word, take its weight modulo 26 and map the result to the lowercase English letter in reverse alphabetical order. Okay. So return a string concatenated by mapped characters. Okay, so what you have to do? You have to take the sum of all the characters weight, and then whatever that weight comes, just take modulo 26 and map it in the reverse order of uh, characters, alphabetical order. Like Z is mapped as 0, then Y is mapped as 1. So in this order you have to map. So that comes out to be, for this, that comes out to be R, and this comes out to be I, and this comes out to be J. Okay, sorry. So in this problem, you are basically given with a strings array, and for each string you have to take sum of weights of that particular character. Okay, so you have to take the sum of weights of that particular character. Let's say it comes out to be your 50, uh, what to say 54. Okay, so it comes out to be 54, then you take a modulo by 2, 26, then it gives how much? 26 to the 54 and 2. Okay, so you get a 2 remainder. Then the 2 will be mapped as Z is mapped as 0, then Y is mapped as 1, X is mapped as 2. Okay, so you will get an X for this particular 54. So you have to do all. Find your return to right. So you have, what you have to do. You got X from this. Say you get A from this. You get G from this. So you have to return a string containing X, A, G. So this is the problem what you have to do, and it's quite like it is there what you have to do. You don't have to do anything else. So just look at the code now because we are not doing anything. Right. So the code looks like we are given a string answer which is empty, and for each s words, what I'm going to do, I'm taking the sum of the values, and you just do an iteration on s, take the sum of the weights, and then do a value model equals to 26 because it cannot ever exceed like beyond integer value. So I'm doing after it. Now you just take your next new character, what it will be in the reverse order. If I'm taking, the character will be z minus value. Okay, then you just append your character into the string and then return a string. So it's quite easy. Like you are what it is there what you are asked. There may be someone who were not able to implement it. but yeah, it is there what it is asked to us. Yeah, let's move towards second. What was the approach for the fourth arc? What did you use? Like I used basic idea of how the path will be made. You go from U to LC of U comma B to B, then you have to. Uh, how did you count it? Like characters? How did you count it the character? Because we have this done a post context decision, I guess last or last second, where I have done a approach on string where I mapped each character as a bitwise operation. Like that was the key idea which I had in my mind, and I implemented the same year. Okay. So let's move towards the second problem. Okay, so this problem asked, we are given an array of string words and an integer k. Now, two words A and B are distinct indices are prefix connected. Okay, if A from 0 to k minus 1 is equals to B from 0 to k minus 1. A connected group is a set of words such that each pair of word is specific is prefix connected. You need to return the number of connected groups that contain at least two words formed by that given word. Okay, so many ads. Okay, so yeah, in this problem you are given with some strings s1, s2, s3, s4 again. Now s1 is connected with s3 if and only if the prefix of s1 from 0 to k. How long this ad is? I can't just open my wait. Yeah, I guess now it's fine. Right. So if s1 from 0 to k minus 1 is equals to s2 from 0 to k minus 1. Okay. So all these values are equal, then I can say s1 and s3 are prefix connected and make them a connected component. Alright. Then I need to just count how many connected components are there. And in one connected component, there should be at least two words. Okay, at least two words. Okay, so let's take an example and understand. Which should I take? This one. Bat, dog, dog, doggy, pet. Okay, so it is bat, dog, dog, doggy, and pet. So K is I guess two or three. Three K is three. Okay. So for K is equals to three. In this particular example, what I'm going to do is I will check what is the prefix of bat up to third index. So it is BAT complete. Okay, so BAT is my prefix. For dog, it is DOG. Okay. For this dog, it is still DOG. So do I need to maintain another string for that? No, I can just make and say that there are DOG and another DOG. So there are total two. So there are total two strings which have prefix dog. Now for this it is dog again. So I can again say that doggy will come with in the same group as dog. So I can add one. So this will be your one and last bat again. So I can increase it by one. So now this contains two and this contains three. So visually, what it look like? It will look like as this. BAT is connected with BAT. It is a one component. And in the second component, dog is connected with doggy. So this is my second component. So I need to count the number of components. There are only two components. I can return two. But no, my just one case was not passing, so I wrote the stuff. Yeah, you know the trick. Now, how will we implement it? Now, as you can see, while doing a dry run, I did not use any more strings for a singular prefix. Like if I have a prefix which is similar for multiple strings, I will use only that string one time. So what I have to do, I will make a map, and in that map I will store prefix to count of that prefix. Okay, and this will keep on going. Now, if I store all of them, then after that I can just check all the elements in the map, all the elements in the map who all are who all have values. English, who all have values greater than equals to 2, then I can increase my count, okay, or answer whatever it is. So I can increase it. So this will be my core logic of the problem. Yeah. So if this is clear, then we can move towards the code, right? And in this code, you can see I made a map of string comma integer, and this string defines the prefix, okay, of each element. Now, for auto iterate words, which means I'm iterating for each on words, and I have to check for all the IDs who have size greater than equals to k, because it is said that it is prefix connected only if and only if it is like 0 to k minus 1. Like if you have a value which is BA and BAT, so they cannot be connected, because if k is equals to 3, this string doesn't have another, like this string doesn't have another letter which is needed to make k is equals to 3 a prefix, k equals to 3 prefix. Yeah, my God, what happened to me? Okay, so that's why I cannot take this aligned with bet. If it was k is equals to 2, then I can take BA as combination with bet, because then the prefix will go up to B and A, and this is common in both of them, so I can take that. So I need to take care of length also, because it should not like be smaller than k. If it is greater than equals to k, make the prefix string, which will be your string dot substring of 0 to k. Very easy. And then you just increase the count in the map. Use the Zod to random detection. Yeah, Zod. Okay, so you used idea. Okay. Now, after that, you just make an answer or iterate over the map. Whichever connected component has number of like strings greater than equals to 2, you just increase the count for that, count those components, and return your answer. So this was the key idea of this problem. Easy. If yes, then we can move towards the third problem. Time complexity, word size into k. Time complexity is word size into k. 5000 into 100, 5v6, 5v5. Yeah, yes. Time complexity is word size into k. Okay, so it will work. It won't give it TD. In the worst case, you can take like word size into the length of the array. Worst case, time complexity, because it will run on big of n, right? And this will run substring. When you take out the substring, this will run on big of k. So you can take n into k. The total time complexity will be n into k. Okay. If you are doing code in like Java, it will still pass. In Java, you have s dot substring function. It will still pass. Yeah. Okay, so let's move towards the next problem. House robber 5. I think house robber 6 is there. When I see this question, I thought first time like house robber 6 was there, then why did they like was there? It is there here or no? House robber 6, I'm not sure. You are a how much would you rate the third problem? 1800? No, not 1800. It's like a mid 15, 15, 14, 15. Look, the idea of this problem is easy. What I mean that you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed and is protected by a security system with a color code. You are given two integers array nums and colors, both of length n, where nums I is the amount of money in the ith house and colors I is the color code of that house. You cannot rob two adjacent houses if they share same color code. Okay, and return the maximum amount of money. Same house robber trick. Look, let me make this problem 1800 to 14 and 1500 for you. Okay, so it is said that there are color set, say A, B, 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 C, C. Okay, so this is my color set. Now, and you have some values. Take some random values. One, anything. Okay, so this is my color code and this is my values. Now, if I am a robber, what I can do? Either I can loot the house or I guess skip the house. Basic house robber trick, right? If either I can loot or I can just skip it. Correct. So if I'm looting, what I need to check? If I'm currently looting this house, just a little. Okay, so if I'm looting this particular house, I will ask you two questions. Okay, if I'm looting this house, then what sum will be added to my set? The sum that will be added is sum up to this house plus this particular sum. Uh, So I can say 1 plus 6, 5 was there. Okay. If I skip this house, then it means either I can take that sum or this sum. Either I can take this sum or this sum. Yeah. I can take the maximum of 1 comma 3. Yes or no? I have a choice, right? For looting, I don't have a choice because for that I have to loot the last second house. Okay. But if I have a choice that I can skip this house, so either I can skip this also or loot this also. So that's up to me. So I can take 1 comma 3. And what is this 1 for this thing? It is just previous looted house. Oh no, it is just previous, like we get the max of alternate in same color. No, 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 no. You don't have idea that you have to take alternate or not. It might be possible like you have to skip two houses in between to get the maximum. Might be possible. But yeah, no, it won't be there. Like alternates, no, no, or you cannot take maximum alternates. You there might be possible like there are two houses in between which you have to skip at some point to get a maximum. Look, what I'm trying to make you understand is that if I'm looting this house, okay, so with blue color, I'm making the looting part, okay. So if I'm looting this house, I will get the amount of money in this house. So let's say it is X, okay. So I get X money, and say all the houses have same color till here. All the houses have same color till here, alright. So if I am looting logically, this means I have not looted this house. Logically, this is correct that I have not looted this house. So what I have looted is the total sum, the total maximum sum up till this house, like up till here. I'm not sure what the sum is. I just know the total maximum sum up till this point. That's what I have looted. Correct. So let's you can denote it with like dpi minus 2. You can make a dp array, but why I need to make a dp array? I will explain you. You can do it without dp. Say this sum is y. Okay, say this sum is y, the total maximum previous looted sum. Okay, so I will say this is y. So your total now will be x plus y. Correct. This is your new looted sum. New looted sum. Okay, please keep my words, like please follow my words what I am saying. This is total of current looting, which is previous skip plus this house, current house. This is just previous skip plus current house. Okay, now if I am not looting this house, so let's make it with 3. Okay. So if I'm not looting this house, then I have two choices. Memoization bottom up. Yeah, it is possible to solve it with memoization bottom up. One of my friend has solved this with memoization, and it works. Just take care of long. Okay. Look, now if I'm not looting this particular house with bottom up 20, yes, 20 TP, house robber is 20 TP. Did it use memoization? Did it even cost me one wrong answer? You can you paste the code here so I can just look at it? Okay. What was the problem? My memoization was giving MLE at 97 test case. MLE. So you might have done a wrong memoization trick, I guess. Like you might have made two witnesses to take care of INJ. Maybe it is possible. You can do this with 1 DP. 1 DP set equally. Yeah. I also did previous minus taken. Look, that's what I'm talking about. Like you have done two indices thing, and it might have given you MLE. I think it will still work, right? Please, can you paste the solution so I can just look at it? I am sure that it will work. MLE is not like an MLE. It's, never mind. Let's come back where we were. Okay, so what I was saying, we are not looting this house. Okay, so please give your attention here. If I am not looting this particular house, then I have two choices. Either I have looted this one, either I have looted this one. Maybe possible. So this thing is y, and this thing, what is this? It is current looting. Okay. So this is not current looting. So I can say current skipping will be equals to your previous skip, previous looting. Okay. I can say that it is maximum of any of them because I want to take the maximum. Memoization should work. Yeah. Memoization should work. It is not possible like memoization give it really. Just show me that what I have done. I can just tell you. Okay. So now it is quite easy. If I have same color code, I can do this trick. like I can skip current index and loot current index with this idea that either I have chosen the previous skip plus the current house for current looting, and if I'm currently skipping, that it means the previous skip or previous looting, the maximum of any of them will give me the answer of current skipping. This is for same color code. What if the color is different? Like this is the color code, and I am standing here. Now I can loot this also this time because I don't. It says that you can only you the police arrives only when a house which is in the same color and adjacent to each other get looted. So if they are not in the same color, which means I can loot this house particularly. So for this, you can just make another condition of where color I is not equals to like color I minus one. Then you can update your looting condition only. Okay, so current looting will be updated. Current looting will be updated as your maximum of current looting, whatever it is, plus a comma, obviously. Now this is also previously looting plus your current household. So this is previous looting plus current household. Did memo and accepted. Accepted. It means accepted. Okay, so if you look at the code, what I've done, I had made a take and no take. Take means looting and no take means not looting. Okay. So now follow me. Okay, if I'm not looting, the value start with 0. If I'm looting, the value start with the first index. Now you iterate over all the elements from 1 to n. You choose your next not looting. Okay, so it is nothing, just let me type it. It's just current not looting. Okay, current not looting the also current no take, it is like that. Okay, which is maximum of previous no take, no looting and current previous looting, the thing which I have explained here. If I am currently skipping, the idea, it is the maximum of previous skip or previous looting, any of them, because if I am standing here and I am skipping this part, I'm skipping this, then I can choose any of them, and this is previously looting and this is previously skipping. Rolling DP. Yes, it is DP. Obviously, it is DP because I am making my current idea from my previous idea, so it is DP. And yes, I have used that like rolling DP idea to make my to update DP at each point. But this is the first thing that comes to my mind. And now this is current looting. Okay, and this is current looting, not looting or skipping. Skipping. Now this is the same thing that I've told you, like you can take maximum of your previous looting and previous not looting, previous skipping, and for if you're looting that particular thing, then you will take the maximum of previous skipping plus the current house. Okay? So this will tell you the current looting. And the second thing which I have mentioned here, like if the colors are different, then you have to take care of current looting part because you can loot again. So if your colors are not same, then you can just update your current looting part as current looting and take the previous looting plus none side. Okay, then update your previous looting and current looting and just return any of them, maximum of take common 8 no take. Yes, is this clear or any doubt in here? I can just re-explain it. Check for color change. You didn't big of 1 minus 20. Big of n. What's a space? Yeah, space big of. You can use a 1D array also. So it's you can maintain these steps. This is nothing like dp of I minus 1, right? dp of I minus 1. Can you do a dry run? Yeah. Let's take an example. This one. 1 4 3 5 1 1 2 2. 1 4 3 5 1 1 2 2. Okay. So this is my example. No. I'm currently standing here. Okay, I'm assuming I'm currently standing here. So there are two choices I have. Either I have looted this, okay, this house, or I have not looted this house. I have two choices, right? So let's take my choice. I have looted the house, so I have one value. And if I have not looted the house, then I have zero value. Okay. Now, if I'm standing here, either I can loot or I can don't loot. If I'm looting, okay, so current looting. If I'm looting, which means I cannot take the part which I have looted earlier. Okay. Okay. If someone has done my voice, please paste the code here, or I will paste the code from my side after the stream ends in the comments. Okay. Look, if I'm currently looting, the thing is I cannot use this part, looting part, which means I cannot loot two adjacent houses if they are of same colors. So first, let's take the idea where all the colors are same. So 4 and 1 has same color. Now I cannot loot this, so my current looting will be your previous don't loot. Okay? No loot, which means 4 0 plus I'm currently looting this house, which is in the name. So I will take 0 plus 4, which is 4. So currently looting is 4. Now, if this is correct, what if I am not looting this house where I'm standing? So I'm standing here, so I'm not looting this house, not currently looting. So either I can choose this part, which means I have looted earlier, or I have not looted earlier. So I can just say either maximum of any of them. I will take maximum loot, comma no loot. So it was maximum of 0, comma 1, which comes out to be 1. So currently not looting is 1. Okay. Not currently looting is 1. Now see if both of them have different colors. No, it don't have different colors. They are of same color. So I will not update my current looting part. Now what will happen is that these value which was looted and no looted will be updated with these values. So this will become 4 and this will become 1. This will become 4 and this will become. Okay. Now can I erase this thing or I can just paste it? You go, come here. Okay. So now my index have moved to here. Now currently I am standing at 3, third house. Now I have again two options. Either I can loot, current loot, or not. I cannot loot. So no current loot. See, I have two options here also. So if I'm looting this house, I cannot use the loot operator. I can only use the no loot operator. So it will be no loot plus current house, which was 3. So no loot is 1. I can write it as 1 plus 3, which is 4. Now, if I'm currently not looting this house, I'm currently not looting this house. So I have a choice that I can either choose this or either choose this. So I can take any of them, maximum of any of them. So maximum of loot, comma, no loot. So it will be maximum of 4, comma 1, maximum of 4, comma 1, which comes out to be 4. So my current loot and current no loot will be 4 and 4. Wait, I have one more thing, which is the difference of both of them. Oh, sorry, the color are different. So the colors are different, which means I can update my current loot as maximum of the which is my current loot, which is 4 already here, 4, comma. I can add up till here loot, which means previous loot 4, and this particular index 3 is 4 plus 3. So my current loot will be 7. Maximum of 4 comma 7 is 7. Okay. Is this correct? Because I equals to plus I minus 1, and then dpi equals to method max of dpi minus 2 comma plus something. If they both are same, then you can either loop, skip loop, and or you take the loop. Yes, if else dpi is equals to. If there are no same, then you have an more idea. Look. Don't write it like this. Uh, Whatever condition is in else, dpi is equals to mat dot max of dpi minus 1 comma dpi minus 1 plus sorry. No, no. You do dpi minus 1. Dpi is equals to d maximum of dp I minus 1 comma I minus 2. This is your take part, and then again do no take part, which is dp I minus 2 plus num psi. So it will look like, I guess, this. It will look like dpi is equals to maximum of uh, first dpi minus 1, dpi minus 2. You can take the maximum of both of them, then do dpi is equals to maximum of dpi comma your dpi minus 2 plus num psi. So you do this, then you check if your color is not is equals to like color of I minus 1, color I is equals to not equals to color I minus 1, then you do dpi is equals to maximum of dpi comma dpi minus 1 plus num psi. So I guess this is the code. This is not, I am not sure, like I'm not sure of it now. dpi minus, should I try it? Okay, so I'm just trying, don't like jump on me for this. Let's do in Java. So, we do long dp to do long size and is equals to long dot size dot length. Just trying. Okay, now your dp of I will be maximum of 0 comma, sorry, I make two of them. What will be the base case? Yes, it will be you show two elements like dpi minus 1 and dpi. So you make a dp of size n plus 1. Make a dp of size n plus 1. And dp1 will be equals to your nums of 0. Then what you do? You do an iteration from n equals to 1, y is less than equals to n equals to 2, and I is less than equals to n, then I plus your dp I, it will be equals to math dot max of dp this one of I minus 2, and then you do dp of I equals to math max of I comma maybe I minus 2 plus nums of I minus 1. Then you do if your color I is not is equal to color I minus 1, sorry, colors I minus 2, and then you do your dpi is equal to the max of I minus 1 plus nums of I minus 1. You do this and just return. I guess this is the code. This is how you write it. Okay. In this way, you have to write it. First, you have to check for both of them, so you cannot do else condition. Okay. So this is what I mean. Like either you can choose the maximum of I minus one, I minus two, or you can do maximum of I minus two, comma so plus num psi minus one, which is just I minus one, I minus two plus num psi. I'm iterating from two to n, so it is okay. So is the key idea clear of this problem? Okay, key idea is clear. What I meant in this problem. If this is clear, then we can move towards the D. Memoization. I'm not sure about memoization. I can write it right now. This is okay. So let's move toward fourth problem. 7 pointer. No response from chat. Okay. So in this problem, you are given an undirected tree with n nodes labeled from 0 to n minus 1. This is represented by a 2D array edges of length n minus 1, where edges I equals to ui vi indicates an undirected edge between u, I, and all three are simple. Yeah, they are simple. Like you can do in this TP format also. I'm not sure why you are doing it like uh, if you are doing tabularization, then you should do in 1D. If you're doing memoization, then you can do in 2D, right? It will work every time. Okay. So you are given an edges and a tree. So in that you are also given a string s of length n consisting of lowercase letters, where si represent the character assigned to the node I. You are also given a string array queries, where each queries I is either update ui comma c, which means change the character at node ui to c. Formally update s ui equals to c. Okay. Now your queries UIVI determine whether the string formed by the characters in the unique path. Unique path. What is the difference between path and tool? Okay, so just tell me what is the difference between path and tool. I cannot get it. Okay, simple. Okay, so a unique path from UI to VI inclusively and can be rearranged to form a palindrome. So we can rearrange all of the character. Return a boolean array answer where answer j is true if the jth query is type of query u comma vi and can be rearranged into palindrome for and false otherwise. Palindrome is a string that reads same in forward and backward. Okay. D problem. I just asked you what is the difference between a path and a tour in a tree. Path, tour, and walk. These three words. Okay. So either right now or after the post contest discussion, you just write in the comment section what is the difference between these three terms. Okay. So this will help you a lot in many ways. Like most of the questions ask for path, some of them which are high rated ask for two and walk. Okay. So this comes in after 18 1900. Okay. So this is path. So in this problem we are talking about path. Okay. So don't worry. Now I have given a tree. This is my tree. Okay. So after being given this tree, I am also given some characters, which is like A, B, A, C, D, A, B, B. Hmm, what to write here? PPT. Okay, so like this. tree is given like this. Now I am asked two types of queries. The first type of query is update u into some character ch. So whatever node it is given, you have to update that particular character with the new character which is assigned. Second type of query is query where you are asked from query u to v. So say your u is here and v is here. You are asked for this query. Okay. So all the characters in this path A, B, A, you need to check if this string after rearrangement forms a palindrome or not. Okay. After rearrangement forms palindrome or not. Now let's move one by one. Okay. So the problem is very huge. We will decompose it in the one by one part. Okay. So first part, how can I check if string is palindrome or not? Palindrome or not. Okay. And before this thing, like prerequisite of one, you need to know, you need to know the path first. Okay, for each query. You need to first know the path of each query, right? You cannot just iterate from like u, then go to v. It will take a big of n time, and if there are n queries, there it will go TLE because of n into q. So how will you know that? How will you get to know the path? How will you get to know the path? Tell me if this is a tree. Let's name it 1, 2, 3, 4, 5, 6, 7. I need to know path from 4 to 7. Just tell me what is the path from 4 to 7. I need to take care of all the characters in this path. Okay. So say there are characters A, B, D, E. No, don't care about palindrome right now. Let's just care about all the characters. I just need to know all the characters in the path 4 to 7. How will you do this? How will you do this? Then you tell me about 4 to 5. Then tell me about F to 6 to 7. Okay, so all these things. Just write in the comments right now. I'm looking in the comments. How will you know the path? Use minimum spanning tree. BAC. BAC. BAC is not a path from like if you are going from 4 to 7, the path is DBACG. So DBACG. So this is path for 4 to 7. How will you get to know this path in like big of uh, like less than big of n? Minimum spanning tree. How will you do that? This with minimum spanning tree? Connecting like you need to know the elements also. No? How will you maintain them in minimum spanning? Okay, so let me tell you what you are going to do. From root, you will take the path up to u. Okay, so path from root to u, then path from root to g to sorry v. You take two paths, root to u, root to v. So it is a b d, and this is a c g. Okay, then you remove the common part. Remove this. Okay, so you removed common part which is a. Now add the LCA u comma v. What is the LCM of u comma v? 4 and 7. It is 1. So element is a. So you add a. So now your path looks like A, B, T, C, G. And when you look at this, it is this A, B, T, G. So you got the path. You got the path or not? It's still in big of like n. I'm coming to that part. Like how will you disintegrate it into big of log n? Okay. Now I got my path in like this manner. Take root to u, root to v. Isn't it? We can rearrange, right? We can rearrange all the characters. It is written the problem, like as you can see where, yeah, you can rearrange into a palindrome. So I don't care about the arrangement. I just care about characters. Okay. So I got the path from root to u, root to v. Remove common, add LC. Okay, so this is now great to see these. Okay, headline for me also. So now you got the path. Second thing arises, how can you check if a string is palindrome or not in big O of 1 or big O of log n, like less than big O of n. How can you check a string is in a palindrome if I am given like a string A, B, C, C, B, A and a string A, B, A? How can you tell that this is a palindrome, this is a palindrome, but this is not a palindrome in big O of 1 or less than like big O of n? I have told you a trick in like last second contest or second contest. It was C problem, I guess. Of div 2 C. Yes. So in that problem, what I have done, I have made all the characters into. I have masked all of them. I have given mask to all of them. Number of character with odd value is one. Yeah, you can make a number of character frequency array, but you should you make should you why should you make array for all of the paths? There are big of and big of Q total queries. You are making part for all of them. Oh, map for all of them. No, you're not. Look, in last second contest, what I've done, I had mask given the mask to all of them. So A will be masked as all the zeros, end with one. B will be masked as all the zeros, then 1 0. C will be masked as all the zeros, then 1 0 0. So it is like this is mask as 1 2 4 and so on, like one left shift with character minus a. So this is what I mean. So I can mask all of them in a 26-bit array, in a 26-bit number. In 26-bit number, I can mask all of them and they will look like in this manner. Right? If there are multiple elements, then I can just check in big of 26 or not. I can check in big of 26 if a number is palindrome or not. So look, I'm giving mask all of them. Okay, so let's ignore the starting zero part because I have number up to C. So I just make this. So this is A, this is B, this is C. Then you do again C, then you do again B, then you do again A. So now to check a number is palindrome or not, that the guy which has said to me that there is only one character, at least one character or at most, sorry. There is at most one character which have a frequency as 1. Okay, greater than 1, or less than 1. What happened to me? Sorry. Wait. There is only one character, at most one character, who have a frequency 1. Is the heavy light decomposition? You can do with heavy light decomposition, like somebody has told in the comments that they have done with light decomposition, but I have not done with heavy light decomposition. I have just done with the idea that I can move from U to LCA then to B, and I can maintain my path using a mask value, which is in the form of 0. Like, you can give mask to all of the characters, and it will become a 26-bit number, and check that number is palindrome or not. Now, how will you maintain all the paths on the tree? You use a Fenwick tree for that, which will keep track of all the paths from U to V, okay? Range paths from U to V. So it will be quite easy to do. Okay, I don't have a great hands on ability for real. So if ABA is a palindrome, which means there's only one character who has single which tree? Which tree? Fenwick tree. BIT, binary index tree. So there is only one character who has frequency 1. Okay, at most one character. So which means if I take XOR of all the elements in the palindrome, if I take XOR, there is only one character left or no character left. If it was like this, you take XOR, all of them will get cancelled. So either it is 0 or either it is only one character. So if I do XOR of all these values, you can see this will cancel out 0. This will cancel out 0. This will cancel out 0. Okay, so I got a value 0. Right? Now, second thing, if I do XOR for this, it is 0, 1, 1, 0, and 0, 1. This will be cancelled out and it will become 1, 0. If I do XOR of this, it will come out to be 0, 1, 0, 0, 1, and 0, 1, 0, and 1, 0, 0. So this will comes out to be 1, 1, 1. Now, either it is 1 bit on or no bit on. Then I can say you can use, then you can say it is a palindrome. If either it is 1 bit on or no bit on, it is a palindrome. What number has 1 bit on? What number has 1 bit on? It is power of 2. So just check if it is a power of 2. Okay. So when you make your mask, just do mask and mask minus 1. If this comes out to be 0, then you can say it is a palindrome. And insert 2. True. Because in the position of the character doesn't matter, right? Yes. The position of the character doesn't matter because we can rearrange it. If it was like written as you cannot rearrange the elements, then 100% the constant were less, because then you have like no idea how to wait. Heavy net decomposition can do in big of log, square, and I guess if it was asked to not rearrange, then heavy net decomposition can do. Not sure. I'm not sure. I'm literally not sure. I can just uh, tell you that it is true only when position of character don't matter. Okay. So now I have two things. I know how to make path. Second thing, I know how to check palindrome. Now I'm going to the third thing, that is maintaining. Let me write it. Maintaining the LCA. How will you get LCA of u comma v in less than big of n? Really easy. You can use a sparse table or binary lifting. Let's say binary lifting technique. Okay, so you can use this and you will get a login LCA. So this is okay. This is like standard thing. I cannot. You can just take the code from anywhere. It is standard. You can take any of the code of LCA available in big of login. Then the fourth thing, what I need is maintaining path from U to V at every node. Now I need to maintain a path from U to V at every node. How can I do this? Like if I am trying to like iterate over U to V path to get the path, it will obviously going to give me a tail. So what I can do? I can use a fan victory in this type of case. Okay. So I will use fan victory to maintain range update and range queries. Okay. Range updates, which was U to V and also range queries from U to V. Okay. So these two are two other things that were asked to me: range updates and range query. Update particular U and update your particular query. Now the thing comes that Anirudh, but family has an array, right? If he has an array, how will I make my nodes into an array? This is my tree, and I'm going from here to here. How can I maintain what path it is? Like, how can I maintain the path? Here comes another trick. Like, all of these are standards. The key idea was this only. Like, you do an LCA and check palindrome in this order. Now, I am using only the data structures and the algorithms to implement it because they are taking a lot of time. So I need to do something like to implement it. Now to convert this into an array, what thing is used? I need to flatten this tree. I am sure most of you have never heard about this term, flattening of tree. It is done using a Leetcode tool. Just take an idea that you keep three things: in time, out time, and the depth of the node. Okay, so these three things are being taken care of. And with in time and out time, you can define a node. Quite tricky, maybe. In time and out time are from like you have done like in time you have done in like graph articulation points thing. Have you ever heard about articulation points, bridges in a graph? If you have done bridges in a graph, then uh, you have heard about what is in time. That the time where you have entered this node. Like if you are standing at one, so you have entered at point two. Then you tour all the subtree of this graph. Like you go here, it go three, then you come back, then you go here five, then you come back and then leave. Then whatever time you leave is the total in time and out time. So it will be seven. So two and seven will be in time and out time like this. So whatever it is, I just know that my in time and out time will define a node which is two to seven. So this particular node will contain a data from 2 to 7. Same for V. I can take for this is V, then I can check whatever time it is and say this is entering at 15. So I will check from 15 and what is the exit time? Let's say it is 16. So 15 to 16 will define me the value V. 2 to 7 will define me the value U. Say this is 3 and 4. 3 and 4 defines me the value W. Any node. So in this order, I can define my each node or the tree into an array. So the second index to seventh index, it will be node u like this. Okay. So I will flatten this tree into an array using Euler's tool. Uh, then I can just use my Fenwick tree to get the idea, to get the current uh, mask of the number, mask of the path. This will be get to me by Fenwick tree. If I first what I have done, I have made a tree, flatten it into, and then insert it into Fenwick tree. Fenwick tree gives me the mask of the path. Okay, now I take three things, which is path, mask of the path of u, mask of the path of v, and mask of the path of the LC of u comma v. Okay. So after that, I just apply my operation and check if it is true or false. This is my key idea. This is clear. Let's look at the code. I guess it is like the data structures and algorithms are like complex, but ideas really okay. Oh, where is the code? Yeah, I'm not showing anything which I've done earlier. Just look at here. You are getting queries. You are getting queries. What you have done? You have checked the type. If the type is update, you just update that particular character u with the new with that particular node u with the character, which means if it is not already updated, then what you do, check the previous mask of that particular character, check the new mask of that particular, like this is path of u, which means the string has u has some previous character, say d. So you check the previous mask, check the next mask, and check what is the difference between both of them. You take so get the difference of both of the masks. Then you update that particular mask from, look what I've done, in time and out time will define a particular node. So from u to v, it is defined by sorry, for particular node u, it is defined by in time of u and out time of u. So I will update that range with the particular difference and update my path of u is equal to c. So now the u has new character c. If it is not update type of query, it is a normal type of query. What I do, I will take u and v as input. Now take out the LC of u and v, which will come from sparse tables. Check, do a query on a in time of u and in time of v using Fenwick tree, and this will return you the mask of path of a and u. Sorry, mask of path of u. This will give you mask of path of v. Now after getting both the mask, you just check the current character, and what I've told you, you do uh, you take first path, second path, remove the common part, and add the character of the LCA. So this is the character of LCA. Now if you do XOR, automatically the same path will be removed, common part will be removed, and then you just do a XOR with C, which means the current element will be added. Then just check if your mask and mask minus 1, which is the power of 2. If it is power of 2, then you can just push back answer as true. So this was the key idea. Only this was the key idea. Now to make this true, which was LCA queries, you need to enter into the heavy data structures, which is first I have made the adjacency list to maintain my tree. Then let's go one by one. So how will you do uh, binary lifting? You make your sparse table, update your sparse table up to 26. Like this is common thing. So sparse table you might have heard about. Okay, so and with that I have also maintained my in time and out time and depth of each of element. So depth is important. Okay, so in time and out time of each node is maintained with a timer, which is global timer, and it increments every single time. If you have done like what was that articulation pointer bridges, you might have heard about this timer. what is this thing, timer thing, and in out thing. Okay, so if you have not heard about this, you can just go to the repo web. There is um, problems pattern 22 series. Check that out. Graph section, and it will be there. Articulation points. Okay, so uh, after doing after filling your sparse table, you need to query for LCA. So query for LCA is the same like the basic sparse table thing. There's a standard, nothing new. Now, after doing LCA of query on LCA, you get an LCA in big of login. Now you need to maintain your uh, mask into the some kind of tree which tells you path from U to B, right? So path from root to U, main thing. So you made a fenwick tree here. Now this is add operation, the standard fenwick tree, update operation and query operation, range update and range query. So it is just standard, very standard fenwick tree, nothing new, nothing I have done as like, and there is a new logic. After that, you just here I have just filled my fenwick tree with in time and out time and that particular mask of the character. Okay? So look what I've done. For each elements of the string, I have take out that mask of that character and update my range with that mask. So in the fenwick tree, so fenwick tree will be filled. After this, then just you can perform all your queries. That's it for this problem. It is hard because of like three things which we are doing, three advanced stuff. First is LCA in big of login. Second is fenwick tree. Third is your in time and out time to maintain like Euler tool or flattening of tree. You need to maintain three different advanced tricks, advanced data structures and algorithm. But idea was like simple. Yeah. So that's it for this problem and from my side. Is there any doubt or like anything you can write in the comments? If no, then we can just end the live stream and meet again later. What is path array? Oh, path array don't show anything. Look. Path array is a string only. I just made a global string path which contains the same value of s. It doesn't contain anything. It's just same value of s. Because I don't want to send in all of the functions each and every time. And all of the functions. So I just maintain all the values here. No, it's not nothing like path has something strict. What is your rank? 500 something like 500. It was 500. So this was the key idea of this problem. Okay, so this is done, we can just wrap up all the stuff. Thank you for joining, guys, and please check out Instagram channel of Repo with. We have planned live streams and a lot of stuff for you there also. And also go to the website, check out Pattern 22 series. We are working on that. We have made some videos, and there is also only quality stuff you will find. Me and Shan and other teams have also worked on that to maintain new problems for you. And that's all for today. We will meet again in the next post contest discussion. Thank you. Bye bye.